Hello friends, welcome to today's class. Today's computer organization and architecture class. So I'll be handling the rest of the topics, and as I had introduced in the introductory class, my name is Vinay Sangoli, and I and Niranjan sir will be handling your CO class. So going forward, this is my email ID and mobile number wherein you can contact me for any queries. So till today you have seen your module number 1 and you have seen various aspects and the concepts of computer organization and architecture, and I hope you have got a glimpse of what actually this subject is, and you have understood the basics of this subject. You understood the basics of this subject, like what is a computer, what are the different parts of a computer, I mean to say what all hardware is involved, what all software is involved, and how the bus structure has been arranged. All these things also has been covered in the first module. Apart from that, you have also seen the various numerical representations, like how do you represent a signed number, how do you represent an unsigned number. You have also seen the memory addressing things, like whether it could be a byte addressing, big Indian, small Indian, then what are the memory assignments. Along with that, you have also seen various memory operations, like to name a few, what are the instructions, what are the instruction sequencing, what is RTN, that is register transfer notation, and what is ALN, which is nothing but assembly language notation. All these things have been covered in the first module. So to move ahead from the first module, there is a small topic in the first module itself wherein we try to discuss between your various computer architectures. Basically it is processor architecture. So here, if you want to discuss the processor architecture, first you need to understand what is an instruction. So an instruction is nothing but a command which is given to the processor, and using this instruction, the processor will carry out n number of operations, which could be addition, copying from a memory, etc. So like this, n number of operations can be carried out with the help of the instruction. So we'll try to touch upon this instruction thing. Usually our instruction consists of two parts. One is called as opcode and the other one is called as operand. Okay, so whenever we say of opcode and operand, it is something like that. Like say for example, this is how I represent my whole instruction. Say the red box which I have shown is nothing but your instruction. Then this instruction is divided into two parts. One is your opcode, which I am just writing it as OP, and the other one is your operand. So this is my operand, which I have written as OPER. Okay, sorry for the unclear things because I am writing it with the help of the mouse. Okay, so what actually is this opcode and operand? Say for example, I want to add two things. Say I want to add A and B. Say A plus B. I want to do this thing. Okay, if I want to do A plus B, this A and B are called as your operands. Okay, A and B will come and fall into this operand section, and the addition, whatever the plus sign you can see here, this addition will be coming in your opcode section. So therefore an instruction consists of two things. One is opcode, which is what operation you want to do. Other one is operand. On what you want to do this addition is nothing but your operand. So if you see the example of one simple example, if I say the same addition, it would be something like this. Say A, the addition is done with the, say I am taking an example of any machine language code. It is given by ADD. The instruction is ADD A, that is the first operand, comma B. So when I write this instruction, it is nothing but you are adding two variables or two operands, which is A and B, and you are using the opcode ADD, which is addition. Okay, so I hope this is clear what actually is an instruction. Okay. So I'll just erase all the inks. So this is how your instruction is being done. That is your instruction, what all consists of. Fine. Now, what actually is this opcode? Opcode usually is very important because based on that you can decide what should be my amount of data. Like say for example, if I reserve some 5 bits for opcode, say I will say that I have reserved 5 bits for opcode. So if I reserve 5 bits for opcode, it means that I can do the operation somewhere around 2 raised to 5. So I can do the operations of around 2 raised to 5. That is nothing but your 32. So this can be done around 32 operations, not more than that. So therefore the opcode length, so this opcode length tells us what would be the range of my data. Okay, now coming to our operand. Operand is nothing but it is data on which the operation is carried out. That's what we saw till now. Okay, so I hope friends the instruction is clear. Going forward, the next very important thing we need to discuss is about your addressing modes. So what are these addressing modes? To tell you about the addressing modes, say I have a location A and I want to move to location B, right? Then there are two things. What is the simple thing? I hope you might have studied about bus structures. A bus will be running from A to B. A bus will be running from A to B. Now, every bus has again two parts. So all those details will go into later way. Now, this addressing modes helps us to communicate between your one location to another location. So these locations can be either your memory locations, or these could be your registers, anything, or this could be your direct data itself. Even that is possible. So if I want to move from a location A to the location B, that is, say if I want to move the data from the location A to the location B, then we use our addressing modes. So this is nothing but it is a way of specifying the operands. How do you specify the operands is given with the help of the addressing modes. Okay. Now, one very important thing regarding your addressing modes is you should be very clear that these addressing modes tells us how the data could be transferred, and based on these addressing modes we will be designing our architecture of the processor, which could be one is CISC, the other one is RISC. So these two architectures will be defined based on this addressing modes. So to tell you more about this addressing modes, or to elaborate more about this addressing modes, say for example I have the number of instructions, n. I have n number of instructions, and these n number of instructions. Now what do you mean by these instructions? Instructions could be anything like, say, add. I want to add two things, it is an instruction. Or it could be I want to copy, say I want to copy two things. Okay, sorry for the unclarity. So say I want to copy certain things. Say I want to copy certain things. So these are nothing but what now? Our instructions, which are given by the n. Now these instructions, how do you execute these instructions? These instructions are executed in the form of the steps. Like, say the first step is I will be adding, the next step will be I will be copying. So that steps are given by yes. Those steps which you perform to implement these instructions, n, are nothing but yes. Okay, I hope I am clear. N is the number of instructions, yes is the number of steps. Now say for example I have a large value of n, that is I have more number of instructions and I have less number of steps. That is, I am executing more number of instructions using less number of steps. Let's say I am adding, subtracting, multiplying, dividing, and then I am also copying with the less number of steps. What happened then? The value of n is more and the value of s is small. Okay, so that is one aspect or one scenario. The other scenario is, say I have an individual instruction but it is performing more complex operations. That is, I have only one instruction and I have only one instructions but which is complex. That is, in one instruction I am doing addition, multiplication and subtraction, and these all are done with only single step. So I hope you are getting it. I have continuously I have addition, then I have a multiplication, then I have some division, and so on and so on, and all these three steps all these three operations I am doing in a single step. I am doing in a single yes. Okay, so if I do something like this, it means that it is the other scenario. So I hope I am clear with the two scenarios. One is more number of instructions, lesser number of steps. The other one is again more number of instructions, but these are executed in only single step. Here I am speaking of less instructions. Here I am speaking of single step, right? This is one way. The other way is, say the same thing, that is addition, multiplication and division, and I am using more number of yes. That means that my n is also large and my yes is also large. This is the third scenario, wherein I have more number of instructions as well as I have more number of steps. Even this we have to deal with. So these all scenarios which I have discussed just now, these three scenarios will be dealt with the help of the different addressing modes. Okay, so I hope this is clear. Now moving ahead, one other very important thing is based on these instruction sets, whatever the instruction set we discussed just now, the computers are generally categorized into two computers. One is RISC architecture, the other one is CISC architecture. One type of architecture we have is RISC, the other type of architecture we have is CISC. RISC stands for Reduced Instruction Set Computer. So I am repeating it once again. It stands for Reduced Instruction Set Computer, whereas CISC stands for Complex Instruction Set Computer. So R you can remember, it is reduced. C you can remember, it is complex. So today's system is just a combination of many of these processors, because whatever the actual design of the processor we have, we need to look after n number of trade-offs. Like if I may get a large speed, but I will not be having a more processing memory, something like that. So these trade-offs has to be taken care of in today's systems. Now what today's systems do is they take the best of both the architectures, that is RISC and CISC, and they will come up with the processor. So I hope I am understandable. They will not implement a single architecture. They will take the best things which is there in CISC, they will take the best things which is there in RISC, and then they will go ahead and they will be coming up with the processor, right? So moving ahead, so we'll discuss the difference between your RISC and CISC shortly. Before that, we'll move ahead with the computer architecture. So what is this computer architecture? Now, computer architecture, see, whenever architecture word, at least you might have heard n number of times this architecture word. Okay, so architecture is nothing but to tell you a simple example. Before building any office or before building any home, what do? You design it on a paper or on nowadays on a 3D machine. We try to design it. Similarly, and in that design, what we decide, where should be my bedroom, where should be my hall, where should my pipeline should go, where should be my kitchen, all these things would be decided in that architecture. Similarly, when we try to build up a computer, then we need to decide what should be my processor speed, what should be the addressing modes I will be using, what should be my memory size. All these things will be decided with the help of this computer architecture. So you can see here, it gives you the details of instruction format. Now instruction format would be, nowadays we have instruction format somewhere around two types of formats we have. One is 32-bit and another one is 64 bits. So what will be having now, these instruction formats whatever we have, it is either it could be a 32 bits or it could be 64 bits. Earlier days we were also having 16 bits. We are also having 16 bits. So when you upload your system with the OS, that is when you install an OS into your system, you might have found out that you have an operating system which is of say 32 bits, 64 bits and so on. So that is nothing but your computer architecture, which would be defining you, telling you what should be my instruction format. Instruction set is nothing but what all instruction sets you are using. Addressing modes, again there are n number of addressing modes, and you should also decide what should be the size of my address bus, the program bus and all those things. Okay, and finally the functional modules. There are n number of modules which would be connecting in your architecture. All these functions modules, what should be my functional modules, what should be, to name a few, your input output module you can take. what should be my input output module, what should be my memory module. That all things will be decided with the help of this computer architecture. So I hope this architecture is clear now. So going ahead, I hope the architecture is clear. The next very important thing is your organization. So what actually is this organization now? This organization is nothing but it deals with how the design techniques are implemented. So this organization tells you how the design techniques are implemented so that the architecture is fulfilled. So this is in real building a system, this is designing a system. Okay, I hope I am clear. This is building a system, this is designing a system. So this usually refers to implementation or realization of the architecture. Especially it is concerned with how you connect the hardware components and how you choose the hardware components, what hardware components are to be chosen, what all will be your various components which I have to connect, and what should be the size of those components will be decided with the help of the computer organization. So friends, maybe today's class I will stop here only, wherein we have tried to cover between what are your various aspects in your CISC and RISC, and I have also gave a short glimpse of what all was covered in the module number 1. In the next class, I will go ahead and discuss the difference between your CISC and RISC architecture. Thank you for attending today's class. If you have any doubts, you can call me or email me or WhatsApp me on this email ID and your phone number.